Greetings, student. This is a recording of one of Garnett's online math lesson classes. You have been granted access to watch this video because you're a paying student and I have seen it fit to provide this recording to you. However, it is important that you know you're not allowed to share this video with persons outside the lessons. This policy is so that my services are kept only to my students. Thank you, and I do hope you enjoy and learn from this video.
These Saturday sessions on factorization. What I will do is, what I may do, and I told you guys anytime we're going to do any past paper, I will let you know, right? I may slip in some past papers, right? I will, when we're looking at factorization, we won't necessarily go to doing past paper questions, but we will look at past paper questions related to factorization, pulled from any paper, right? I will do that. Now, what just happened? I don't know why that happened. Yeah, right. Now, the first thing I will go through is the forms of factorization. There are multiple forms of factorization that you need to be able to use, right? And you will be able to identify which form you have to use it at a given time, that kind of thing. I will break down what is factorization and what are factors. The two words will come up a lot. So we need to cover and ensure everybody understands what those terms mean, right? And we'll go through identifying factors from algebraic expressions. Now, this is the part that I want to skip, right? We will go through this, but I won't go through it the same way I went through it with the previous class. I will go straight ahead into some of the forms of factorization, right? Going through some of the forms of factorization. And in going through that, you will see how to identify factors for algebraic expressions. Because I think the way I was doing it last time caused some confusion in the class, right? So I learned from that. Now, there are more or less 4 forms of factorization. There's a lot to learn when it comes to factorization. That's why we need at least 3 Saturday sessions for me to completely go over everything, all right? It's a lot to swallow, but one thing that will help you in maths, and generally in maths, not just with factorization, one thing I hope you remember this stuff to do in maths is practice, right? That's maths is a practice, it's basically a practice game, right? Once you're practicing maths. When I was while I was doing maths at UG, my math lecturer used to tell us to do a math problem a day. Every day you have got to be doing some math problem. Things like that would help, right? I ain't getting you have to do a math problem a day. However, as we get closer and closer to the exam, I'm gonna start hitting the gears and we're gonna start doing a lot of practice, because again, practice is math. Math is a practice game. You practice enough times and you will get it, right? It will be committed to the concepts and so on, will commit to memory. And it's not like social studies and the other subjects where you gotta memorize certain things. Once you practice enough questions, you keep practicing and applying the concepts, you should be fine. Right, so there are 4 forms of factorization, 5 here, but more or less broken down into 4 forms. You have using, this is the easiest one, using the highest common factor, HCF, what is known as the highest common factor, and the distributive law. Now, you don't need to necessarily take this down. We will go through them step by step and you will see, right? So you don't necessarily need to copy this, but we'll be using highest common factor and distributive law. And what you will see as we go through is that the funny thing is, when we factorizing quadratic expressions, like as a perfect square, as a product of 2 binomials, you will be using the highest common factor and you will be using by grouping and so on. So even though these are the forms of factorization, they are all interconnected. It's maths, right? Most of the stuff repeats itself. So these 2 are the most important ones that you need to conquer. Once you grasp this properly, you will see how easily this factorizing the difference of 2 squares. They should be squares, and factorizing quadratic expressions will come just by conquering these 2. right? So yes, it looks like a lot, but as I said, these two is the one that you really need to get a full, you really need to fully conquer, and you will get the rest, right? It's just some added concept you gotta remember, some added steps, and you're golden. So what is factorization? What is factors? That kind of thing. Now, factors is a number. We went through terms. I explained to you guys what terms are. Terms are separated by plus or minus sign. And those expressions that are separated by that plus or minus sign are made up of factors. That's what we call them in maths. We just call them factors. And the reason why, yeah. Now, from a factor, we can draw factor, even more factors from it, right? And that's what it says here. So a factor is a number or algebraic expression that divides another number or expression evenly with no remainder, right? So factors in this sense refers to, there's an example at the bottom here that is, I think, going to explain it better, right? And factorization refers to factoring. You're re-expressing the expression in terms of its factors, right? So factors is any number or an algebraic expression that divides that expression without leaving a remainder. That's primary school. If you don't remember that from primary school, a factor divides. Once you can take that, whatever you're calling the factor, like let's say 15, the factors of 15, two factors of 15 is 3 and 5, meaning that if I divide 15 by 3 or divide 15 by 5, I will have no remainder. You will get whole numbers, right? Those are factors. This is the concept behind factors, right? Factorization just takes it a step further in that you're re-expressing the expression, right? You're re-expressing the mathematical object or expression in terms of the factors. So that's what the second point is saying. Factorization or factoring consists of writing a number or another mathematical object expression as a product of several factors. So it's usually going to be a product, and it's going to be more than one factor. So looking at 15, the factors of 15, two factors of 15 are 3 and 5. Those are not the only factors of 15. We also have 1 and 15 also. But we can re-express 15 as 3 times 5. Right? This is factorization essentially. You're taking a mathematical expression, a number, and or a mathematical expression, and re-expressing it as a number multiplied by something else. One of the factors of that expression multiplied by another factor of that expression. And this is it looking at an algebraic expression. We have x squared minus 4. We break this down as x minus 2 multiplied by x plus 2. Right? This is factorization in a nutshell. You're just taking an expression or a number and re-expressing it as something multiplied by something. So easiest way to do that is 4. Right? One is simplest way to 4. You can factorize 4 into 2 times 2. All right? Into 2 times 2, you can factorize 6. You can factorize 6 as 3 times 2. Right? That's factorization. But there are different methods to it, especially when we're looking at algebraic expressions. Let's go straight ahead into using different methods of factorization. Right? I said I will skip the process of identifying factors. Right? We will do that while we look at the methods. Right? So identifying the highest common factor is usually the first step when you're factorizing, meaning that we got to identify what's the highest common factor, and I'll work an example and show you exactly what that is. Now, using the highest common factor or the distributive law, more or less this, in general, this is how we factorize, right? We take the common factor. I take the common factor of both expressions, right? Again, we have two expressions and we're factorizing this entire expression as a product of some expression multiplied by something else. In this case, it's a plus 5 multiplied by x. This is factorization, right? So in this example, the factors are x and a plus 5, and those two are multiplying, right? And those are the factors of ax plus bx, right? Now good. So here we have a better example. It's the, all right, good. Yeah, so here we have a bad example. And in this case, what you will see, there is still some markings there. But what in this case, what you'll see is that we're doing it backwards. And yeah, we're doing it backwards, but with number. Now, before we use the distributive law to factorize, you guys need to know what distributive law is. So the distributive law says for an arithmetic operation deals with the multiplication of numbers in brackets. It goes out now. All right, so I will go through it this way. Right. So yeah, the distributive law deals with distributing over bracket. That's mostly it. When you're multiplying an expressions in brackets, right? How you distribute multiplication over a bracket, especially a bracket term, right? So it goes as this: if you're multiplying 3 times open bracket 4 plus 7, most of you already know you take your time and multiply each term by the number outside the bracket. So if it's 3 multiplied by open bracket 4 plus 7, yes, you can add them. Yes, you can go ahead and add them. However, the distributive law says that we can do it this way. We can multiply 3 times 4, 3 times 4 plus, then that addition comes back. 3 times 4 plus 3 times 7. That's the distributive law. If you didn't know, if you have been doing that before all the time and you didn't know what it was, there's a term for everything in maths that you're doing, even though you might not know the name. So this is the terminology for what you're doing here, right? This is called the distributive law, and it says that, yeah, it says that you can multiply bracket terms by multiplying the individual terms by the expression outside, right? The number outside here. The same thing, and you can get the answer like this. All right, the same thing here, again, the same thing. But what you want to point out here is that this, where this minus sign goes, it doesn't disappear. There's 2 ways you can do it actually. So it's 5 times 4. Again, you're multiplying the terms in bracket. You're taking your time multiplying the term outside, the number outside, by each term in the bracket. So 4 times 5, or 5 times 4, same thing, minus or plus, right? I will show you guys that just now. So, or we can do plus 5 minus times negative 15. So you notice you can still use a plus sign, right? Even though it's negative. However, another way to do it is to put the minus sign instead, right? Another way you can do it, if you're multiplying 5 times 4, right? So 5 multiplied by 4 subtracted by 5 times 5, right? So I put the minus sign here instead. 5 times 5, you will end up back with the same thing, which is 20 minus 25, right? Which is equal to negative 5. So you can do either one. You can actually still be adding, even though there's a minus sign here. You just need to remember that it's a negative 5. You can treat it as a negative 5, or you can treat it as a 5, but doing a subtraction between the two expressions, right? So that's the distributive law. It's just multiplying, opening out your brackets. Yeah, it's basically just computing your brackets. You multiply each term by the number in the bracket, and don't forget to put the operation between them in there, right? Even if it's a subtraction sign, you can't put addition, or you can just put the subtraction, right? Do it either way, you will still end up back with the same answer once you're multiplying the terms correctly, right? So that's the distributive law, right? It's how you distribute over a bracket. Now going back to this. Yeah, going back to this, no. Let me show you an example. Let's go to an example first instead of me. Good. Now, the distributive law will come up when we look at factorization in terms of this, right? Good. So the expression here, the problem is asking us to factorize the following expressions: 5x plus 5y, then b For question B, we have 25x minus 10. Now, when you're factorizing, the first thing I like the persons to do is you have two terms here, right? You have two terms here. Depending on the amount of terms, will dictate what method you use to factorize and that kind of thing, right? So for 2,
Sir.
Yeah.
Sir.
Yeah. You just got disconnected.
Sir, this Wi-Fi acting stupid.
Yeah, I just realized you got disconnected. All right. Yeah, so the first step of factorization is 5x plus 5y. Now, the first step in factorization, particularly when you're looking at algebraic expressions, right? The first thing you want to do is look at the coefficients, right? That's the first step. Look at the coefficients first, and then you deal with the variables, right? Those are what we call variables, x and y. So the first thing here, it's 5, right? Now, how to identify factors is actually this way, right? The factors of 5 are 1 and 5, right? 5 is a prime number. The factors of 5 are 1 and 5. Why? Any one of you can answer that question.
Only 5.
Only only 5 will go into 5. This isn't.
Sir, because 1 could go into 5 and 5 could go into 5 without leaving a remainder.
Yes, that's it. That's the reason, right? Because 1 can go into 5 and 5 can go into 5 without leaving a remainder. And there's no other numbers that can do that without leaving a remainder. So we have all the factors of 5, right? This is the coefficient of x. Luckily, the coefficient of y is also 5, right? So, and the factors of 5. Now, I know you guys won't be actually doing this, but these are all the steps, right? You might be skipping, when you do enough factorization, you know the factors of 2 numbers just by looking at it, you know the highest common factor. It will come to you easily, right? But I'm taking my time. So for the first coefficient of x, right, this first expression, we're factorizing this entire expression. But for this first term, 5x, we're looking at the coefficients first, right? So 5 and 5. So the highest common factor here, meaning that the highest common number between these factors, which is 1 and 5, the highest number is 5. So this is what we call the highest common factor, right? It's the highest value, right, between the two factors. Right, is the highest common value between the two factors. Forgot to say common, right? So that's the way you identify the highest common factor. So that's the first thing you do. So we have our first factor of this expression, right? Identifying the highest common factor is the first step in, as I said before, is the first step in factorizing by highest common factor and distributive law, right? So the first step is we have our highest common factor, which is 5. So you're halfway there. Remember, we're taking this expression and expressing it as something multiplied by something else, right? So we have that half of that something, we have the 1 something. It's going to be multiplied by something else. And what that is, it is the expression divided by the highest common factor, which is 5. So you just take the highest common factor, and divide it by the expression, right? Now, the easiest way to do this, I believe, take your time because it's going to be more than one terms. Divide it like this, right? You can do these in your head. You can actually do this in your head. So 5x divided by 5, right away, you can see the 5 will go out to the 5. Same thing with the 5 with the y. So you end up with x plus y, right? Everything else is canceling out. So you end up with x plus y. And that is the next term for factorizing 5x plus xy, right? So x plus y is the second factor of this expression, right? So x plus y. So we end up with 5 multiplied by, there's an invisible multiplication sign there, plus y, right? And this is the factorization of this. Now, good. So we have 25x minus 10, right? And they're asking us to factorize this expression. Again, the first thing you look for is the numbers, right? The coefficients or the numbers. So 25, we have 25 and 10, right? We're using this method of factorization because that's the one we see here, right? So the factors of 25 are 1, 5. Anybody else can find any other factor for 25?
Sir, 10.
10 is our factor 25.
Sir, 25.
And we have 25. We have 25. Right. What's the highest common factor between 25 and 10?
5.
5, right? Because, right, this is the primary school stuff. So the highest common factor here is 5, right? Good. So the highest common factor is 5. So we have part of the answer, right? 5. Now the next step, take the highest common factor and divide it by each expression, each term, right? So we have 25x minus 10. Just take you can do this in your head, right? If you can do this in your head, you can do it in your head, right? So you can take it, divide it, get your open bracket, divide 5 by 25x, right? We know already that we just need to, we're just going to be dividing the whole numbers, right? So 25 divided by 5 is 5. 5 is 25. So here we end up with 5 into 25 is 5, right? So in here we end up with 5x, and 5 divided by 10 divided by 5, sorry, is just 2, right? So you end up with 2 here. So you end up with 5x minus 2, right? Don't forget, don't let this x escape you, right? So 5x minus 2, and that is the second expression, or the second factor for the expression. That's the, I'm taking the long way of doing this, right? Right, so this is the answer. Now, according to the distributive law, so I'm gonna segue here and just, so we have 5 open bracket x plus y, right? This is the factorized version of this. Now, anytime you're doing factorization, you should be able to go back to the original expression because all you did was re-express it, right? Because that is factorization, just re-expressing it. You're writing it in an easier form. So if we were to look at the factorized expression, we should be able to go back here. And that's where the distributive law comes in, where you multiply, again, you multiply the first factor, right? The 5 multiply, and just distribute it over the bracket, right? So 5 times x would be 5x plus 5 times y is 5y, right? So, and we end up back with the original expression. Same thing over here. 5x minus 2, 5 times 5x is 25x, right? Because you multiply coefficients, multiply by the coefficient. And 5 times 2, well, we're taking it as 2, right? So minus, and then 5 times 2 is 10, right? Do it that way. So you see here, when we do when you factorize, you should be able to go back to the original expression, right? Using the distributive law. That will happen throughout, no matter which method you use, you should be able to use the distributive law to go back to the original expression, right? That's the thing about the distributive law. Now, one thing I will tell you now, let's look at, so the numbers here is 64 and 16. All right, yeah, so the highest common factor here, let me see if you have to jump ahead.
8. So 8.
Yeah, give me 8. But I honestly never list all the factors for this. But let's go ahead and do that, just for the sake of it. So we have 4. 16 actually is it. Yeah, 16 is actually it.
Oh yeah.
We have 16. 32. If I'm missing any factors, let me know, right? We got 4. We got 8. And then we have 16. Don't think I'm missing any factors. All right, so these are all the factors, meaning these are all the numbers that can divide by 64 and leave no remainder. Same with 16, right? These are all the factors. So the highest number here you see is this, actually the 16. I was thinking 8 too, but 16. So the highest common factor is 16. Right. So we have it now. Now, one thing what I can tell you about the highest common factor is that it could be either positive or negative. You actually decide whether it will be positive or negative. Because if it's a negative 16, right? If any one of these numbers are negative, it can still divide. Yeah, it can still divide into these whole numbers without leaving a remainder. Right? So it doesn't, so necessarily by convention, when we think of factors, we think of positive numbers and we start dividing the positive numbers like this. But in actuality, if I was to put a negative on each one of these numbers, it would still be correct, right? Because -1 can still divide into 64 without leaving a remainder. It will just be, however, it will just be -64 instead of, it will just be negative, right? But it won't leave a remainder. Remainder meaning a decimal, right? Notice it doesn't matter what sign there is. Once it's not a decimal, right? It's not leaving a remainder, right? So all of these guys can be negative. So before we were just using the positive numbers, right? Before we were just using positive highest common factors. You can actually use it as a negative number, right? Having already figured out that it's 16, you could use -16 or +16. You could have done this over here, but the reason why I bring this up this time was because both numbers are negative, meaning this is a -16 you're looking at here, and this is a -64. And because of that, people don't like it if you teachers will like it if you use the negative, right? Meaning that you actually factorize the negative as well as when you're using the highest common factor, you actually factorize it with the negative, right? So -16 instead of 16, right? I will do it using +16 too, right? Just to show you guys the difference between the answer and how they're actually the same thing. It doesn't really matter. Being honest with you, don't use a negative or use it. The answer is still going to be the same. You shouldn't lose marks because of it. I don't think anybody will penalize you because of it, but you should know that it doesn't matter whether it's negative or positive, you will get the same answer. Mathematically, it will be the same answer, and I will show you that just now. So we have the highest common factor, and that's -16. Now we have to go ahead and divide -64. So you can do this in your head. right? Negative 64 by negative 16, we have negative 16, right? Then minus, well, yeah, minus 16 divided by negative 16. You could do minus negative 16 divided by negative 16, or you could divide it like, all right, Tosh. Let's do it. Let's take our time and do it like this. All right. So right. So negative divided by negative cancels out. And negative divided by negative gives you a positive. All right. So negative and negative divided by negative is positive. So those two go out, give you a positive sign. Now 16 divided by 64 is 4. Right. So we just left with 4x over here. Right. So negative 64 divided by negative 16 is just positive 4. Right now over here we have 16 divided by negative 16. The negative didn't go anywhere, so 16 divided by 16 is 1, right? The 16 divided by 16 is 1 or negative 1, right? If we want to scratch out the sign, but the negative didn't go anywhere, so you end up in negative 1. Right? So what you end up with here is 4 minus negative 1, right? Because remember this minus sign is still here, so you end up with 4 minus 4x. Sorry, I almost forgot the x. Right. But 4x minus negative 1, and because we have a double negative, I notice I didn't put, don't ever do this, right? I'm telling you this from now, so I don't see it, right? We end up with 4x minus negative 1. Don't ever do this. Math teachers don't like when you do this, right? Put minus and then a negative sign, right? If you want to put it being minus by negative 1, you put it in bracket. I put it in bracket. That's better, right? To put it 4x minus negative 1, you can put the negative 1 in bracket. Do that, or what I'm about to show you is that once you have a double negative, and a negative makes a positive, right? Once you have a double negative like this, it becomes positive, or it becomes a plus sign. Think as this being this dash and this dash goes together to create a plus sign. You can think of it like that if you want, but a double negative gives you a positive sign. So 4x plus 1. So we end up with plus 1 instead of minus negative 1. So minus negative 1 is the same thing as plus 1. Right? It's a double negative. Double negatives cancel each other out to give you that positive. Right? So the expression here now that we left back with is 4x plus 1. Right? So open bracket, 4x plus 1. Right? If we factored with negative 60. Now let's do it with positive 60 now. Same thing. Negative 64 x minus 16. And we're dividing it by positive 16. Right? So you end up with, though negative sign isn't canceling out over here, so we just end up with 4 negative 4x, right? The 16 goes out, and minus 16 over 16 is 1. We just did that one, right? So 16 divided by 16 is just 1. No negative sign on the 16. Yeah, no negative sign was on the negative 16 here, so it's just minus 4x minus 1, and that is minus 4x minus 1. Right? So in this case, it's minus, open bracket, minus 4x minus 1. And mathematically, there's no difference between negative 16, open bracket, 4x plus 1, and 16, open bracket, negative 4x minus 1. There is no mathematical difference, right? If I was to use the distribution law, right, which says that you can distribute by multiplying each term by the factor in front, if I was to use the distributive law, but instead of actually distributing the 16, I distributed the negative sign. The negative sign would go on the negative, would go on the 4x, making it negative 4x, and the negative sign would go on the plus 1, making it minus 1. So that's how you can go from negative 16 open bracket 4x plus 1 to 16 open bracket negative 4x minus 1. Right? It's just one you actually factored out the negative sign, and the other one you didn't, right? You didn't bring out the negative. Okay? So this one we didn't bring out the negative, and here we did. And we could always distribute it back in and end up back with this answer. Any questions or confusion so far? All right. Okay. We're not done yet. I'm not finished showing you guys examples. We got examples, right? Now, so I don't want this guy in my way. Right, so we have two answers here. Right, both are correct. You do any which one you want. But people like this one is preferred, but it's the same thing. It's the same thing. So 64a squared minus 8a. Now this time they're following the same method. Luckily we already have the factors for 64 up here. Let's write it back. So 64, 1, 2, 4, 8, and 16, 32, and 64. For y'all, for those that are brighter than me, I know you guys can just look at it and get the highest common factor, right? But let me take my time. So for 8, we have 1, 2, 4, and 8. So right away we see here that the highest common factor is 8, right? No, the highest common factor is not 8. It's so yeah, the highest common factor between the numbers is 8. So we have 8 here. That's the first thing we do. Identify the highest common factor between the coefficients or the numbers, right? I say numbers or coefficient, right? Numbers and or coefficient. So we have our 8. Now we don't go ahead and start dividing. What we actually need to look at next is the variable. Before, you notice that the x, you only had one x variable over here, and for this one you only had one x, and for this one was x and one was y. The variables weren't common. We don't have common variables. So when you're looking at the highest common factor, you don't just look at the highest common factor between the numbers. You actually have to look at the highest common factor between the variables. The reason why we didn't look at it before is because we didn't have any common variables. But now we do. We have a. A is in both expression. So we have to go an additional step to actually get the highest common factor for this expression. So we have the first step, which is the 8. Do the numbers and then look at the variables, right? So the variables here is a and a, and a is in both. And you take the, what you do here now is you actually take the power of, you put a because you're going to factorize a because a is in both expression. But what you do is the power of a depends, you take the power of the lowest a, right? You take the power of the lowest variable, the lowest common variable, right? So it's a square and a, the power of a square, the power of this variable a here over here, it's 2, and the power here over here is 1, right? It has no power, which means the power is 1. So you take the lowest power, right? That is the highest common variable. Now, let me do it this way. Think of it like this. That's the short, that's the simplest way to do it. Just take the one with the lowest power. So a square and a, you just take a. So 8a is the highest common factor. In actuality, this is what you're doing. So you have we're looking at the variables for a square and a, right? The factors, sorry, not the variables. So you would have to list the factors and identify what's the highest common factor. So between a square and a, 1 is a factor of everything. So because 1 could divide by anything and leave without leaving a remainder, right? So that's fine. Now the second factor for a square is actually a. Same thing with a, right? A square is a, and then a square, right? If this was, let me look at it. Let's look at this. Let's look at another one. B to the and b to the 4th. The factors of b to the 3rd power is 1, b to the b square, and then b to the 3rd power. You stop there. The factor here would be 1, b the factors of b to the fourth power would be 1, b squared, b to the third power, and b to the fourth power. You notice what I'm doing? If you notice what I'm doing, I am just actually increasing until I reach, start with 1 and then increase the power of the variable until I reach the same power as the original expression. So for b to the fourth power, the factors are 1, b, b squared, b to the third, and b to the fourth. Now this is because if I divide b by b to the fourth, I will have no remainder, right? If I divide b to the third power by b to the fourth by b to the third power, the b's will just cancel out and leave you with b. So you just have cancellation going on. So for that reason, right? So these are the factors. So the highest common factor here would be the a, and that's how we identify that. And the highest common factor here would be b to the third power, which, as I said before, it's actually the power of the lower, the variable with the lower power, right? It's always going to be that. Don't want to, you could do this a million times, do it this, take your time and do it like this a million times. You will notice that you will always end up having to use the variable with the lower power, right? So jump, so that's why I taught you this first, because this is more or less what you're going to be doing. Just looking for the one with the lower power and using that instead of actually writing this down, right? I know you guys will skip this as well, right? So you don't have to do it like this. You can just take the one with the lowest power, right? And this is the reason why. Good. So the highest common factor is actually 8a and not 8 because we have common variables, right? The variable is common. The next step is always the division step, right? Let me erase. Actually, let me leave that. The next step, it's the same as always. So 64a squared divided by 8a, and then we're dividing this 8a by 8a, right? 8 cancels out with 8. A divided by a, 1. So just end up with 1, right? 8a divided by anything divided by itself is 1, right? We know that, right? So 8a divided by 8a is just 1. Let's come over here. We have 64 divided by 8, right? A squared is 64, right? So 8, right? So 64 divided by 8 is 8, and a squared divided by a is a, right? We just leave back with a. Reason being is because I'm writing all over the place. Think of it like this: 64. A square is the same thing as a times a. So if you're dividing that by 8a, a will just cancel out to one of these a's, and you're left back with an a. That's how that works, right? So a squared divided by a will just leave you with a. You can multiply it out like this and see how the a cancels out one of the a. And when we do laws of indices, you get a better understanding of that. If you haven't done laws of indices as yet, we will cover it, not to worry. But for now, this is how I'm showing you guys to do it. Okay? So we end up with 8a over here, right? So this is just 8. One of the a left back, and 64 divided by 8 is 8. So you end up with 8a minus 1. And this is our second expression. Wow. Now, believe it or not, when you're factorizing, at least you won't be writing any of this. You won't be writing any of this. You shouldn't be writing any of this. You should be, right now, none of you should be writing any of this when you're factorizing, right? You should be able to look at this, identify that 8a is the highest common factor, divide 64a squared by 8a in your head, see that it's equal to 8a, and then minus, then put back the minus sign and divide 8a by 8a and get 1, right? So we're going to practice that. We're going to practice doing it like that. Before I'm honestly babying you guys, entertaining some baby stuff by doing it like this, right? Now we're going to go ahead and actually look at it and work it that way, right? It's faster, and look how much space we're taking up writing all of this stuff, right? Any questions so far?
No, sir.
Everybody following?
Yes, sir.
Don't have this answer. All right, Elisa goes to know that you're following. We gonna study the rest of them. All right, good. So here now we have negative 4x squared plus 2x. Right away, somebody give me the highest common factor.
4, sir.
So I said 4. Pardon? Denisha said 2. This part of it. 2x. 2x, right? You forgot the x. Remember common variables. So you found out the highest common factor between 4 and 2, right? So 4 and 2. I gone back and write and baby y'all again. Right? So 4 and 2, the factors of 4 and 2 is of 4 is just 4, 2, 1, 2, and 4. Right? And the factors of 2 is just 1 and 2. So the highest common factor here between the variables or the numbers is just 2. And we also have to check the variables, especially if they are common variable, meaning that x, you have the same variable in both expressions. So next thing you check for common variables in both expression, here it's x, and you just take the variable, the one with the lower power, which is just x, right? This x is x to the first power. So the variable, the factor, the highest common factor is actually 2x, right? Now, negative 4x squared divided by 2x. It's the other way around. Negative 4x squared divided by 2x. Divide the numbers, then divide the variables, right? Negative 4 divided by 2. So just do it like that, right? Negative 4 divided by 2. That would just be negative 2. Right? Or negative 4. I got my beat me out. But yeah, negative 4 divided by 2. 2, right? And the negative still stays. Now, x squared divided by x, as I explained before, you can think of it as, yeah, I explained before, you end up with negative x, negative 2x. But as I said before, you can think of it as this, right? X times x, so that you can see that this x goes out, right? And this 2 and this will leave you with 2. So negative 2x is the answer. And then we have plus 2x divided by 2x is 1. Anything divided by itself is 1, right? So the answer here is 2x open bracket negative x, negative 2x plus 1. Right? Let's go through this one, see how fast you guys can do this one. 81x squared minus 9x, highest common factor.
Or 9.
9. You're missing something.
9x, sir.
9x, right? Don't forget that x. Once you see the common variable, gotta get that x in there, right? So x, right? Now open bracket, 81 x squared divided by 9x would be divide the numbers. 81 divided by 9 is 9, and x squared divided by x is x, right? So 9x minus 9x divided by 9x, 1, right? Anything divided by itself is 1, right? There's a pattern here, right? This is actually this is the perfect square. 9x is a perfect square of 81x squared, meaning that if I square 9x, I will get 81x squared, right? So, and that is the same thing over here. 2x is actually the perfect square of 4x squared, right? That's the reason why that's a pattern there. All right, so you don't need to think that, but so we have now some additional. So we have now some additional problems. Any questions or queries so far? Everybody following?
Yes, sir.
All right. So as I said before, these are the fundamental things that are going to be coming up when we're factorizing. Identifying the factors, right? The highest common factor, and dividing the highest common factor by that. That's going to keep popping up no matter which method we go forward, right? Even though it might be adding some complexity to it, it basically, that's the fundamental thing about factorization. Identifying factors, the highest common factor, and actually this dividing, right? Now here we're stepping it up a bit, and what's that doing there? We're stepping it up a bit with 3 expressions instead of the 2, right? And you notice that I'm actually factorizing 2 expressions, right? And that's when you use this method of factorization, this method where you find the highest common factor between those 2 expressions, then divide the 2 expressions by that highest common factor. That method, the distributive law, using highest common factor, that method, you more or less do it when you have 2. So we're adding some complexity, making it a bit more difficult. Now we have 81. I see if y'all could get this one. You have 81, 36, and 45. What is the highest common factor here?
9.
9, proper. I like that. 9, right? The numbers is 9. We could use -9 or +9. Don't forget it, right? We could use negative or +9. But we also need to look at a variable. This is an L, so we have L in each, right? And all the L's have the same power, so we don't need to bother with that. Okay? Now, you might be inclined to think that we have B, so we should probably put B here. But no. Anybody want to guess why not?
Sir, because it's in the all.
It's not in all, right? And we're factorizing the entire expression, right? We're not just factorizing these two. If we were factorizing these two and ignoring this, then you would take out the B and factorize like that. But we're factorizing this entire expression. So we need to ensure that the variable is in each term, right? So well done, Emma. That is exactly why. So we have 9L, right? Open bracket, negative A to 1 LA divided by 9L would be, all right, did I write this one out? Fancy. I can't figure out how to do that. The fancy L. Let me write it as a L, right? LA divided by 9L, right? The L and the L goes out with each other. A to 1 divided by 9 is actually 9. So minus 9A. Right? This one, same thing. LL goes out, 36 divided by 9 would be, well, minus, I put the sign. You could always bring back this sign, right? The signs, you could bring them on because we're just dividing the number. Right? But so 36 LB, 9 divided by 36 divided by 9, sorry, would be 4. L and the L will cancel out, so we just end up with minus 4B plus 45 divided by 9. 5. L cancel out, that back with B. So this is the answer for that one, right? Now here, let's see how you can get the highest common factor here. Good. All right, so now here, this one is a tricky one. This is a fraction. All right, a few minutes. Now I want to guess what's the highest common factor. All right, so the way to do this one, you rarely see expressions with, they're asking you to factorize expressions with fractions in it. Right? You rarely see it, but I'm gonna try and prepare you for everything. Right? So with the fractions, just take your time. Do it like this. This is the way you could do it. But you know you're gonna end up with a fraction. You're going to be the highest common factor, at least the number will be a fraction. The easiest way to do it is like this. The highest common factor for the numerators and then the highest common factor for the denominators. Easiest way you can do this. So the highest common factor between 4 and 1. Anybody can answer that. The highest common factor between 4 and 1.
4 or 4.
Anybody? Oh yeah, saying 4. Look at this. The factors of 4, 1, 2, and 4.
Sir,
the
1.
Factors. Gotta say 4. The factors of 1 is just 1. So the only highest common factor will be 1. So you end up with 1. The highest common factor between 3 and 3, right? So we end up with 1 over 3. So that is the highest common factor between the fractions, right? So anytime you're dealing with numbers and fractions, just take your time and do the numerator first and the denominator first. I can guarantee you that works, right? So, right, so be careful though. Yeah, saying 4, right? So we have, next we have the variables, right? We got to make sure we look at those variables. So we have pi in both, right? So pi comes out, right? They're the same, is the same power. So we got rid of the pi. So we factored out pi. And the next is the R, right? R is in both. H, we could ignore H because it's not in both terms, but R. So we have R to the third power here and then R square over here. So we'll be using R square, right? So R square. Good. Now we divide. Now we divide this by, okay? Now we divide either these expressions. Right now we actually, yikes. So now we have our, this is the highest common factor, 1 over 1/3 pi R square. 1/3 pi R square, almost we can volume formula or something like that. But yeah, right. So next, what we would want to do, well, we know of course that pi and pi is going to cancel out. We know the r's. This r square is going to cancel out 2 r's from this r to the third power, which is basically just 3 r's. 2 of the r's from these 3 r's will cancel out and just leave you with 1 r. So you're left with r, but 4 over 3 divided by 1/3 would be. All right, so let me do it. So 4 over 3 divided by 1/3. We flip the right-hand side and change the sign to multiplication. Have it 3 over 1. You can cross, see these two cancel out each other. Or you can go the long way and do 3 4s 12. 12 divided by 3 is equal to 4. Or you can just see that these two cancel out, you end up with 4, right? Good. So 4 is the answer here. So 4r, right? So again, just divide the number, the coefficient. That's the way we've been doing it, right? Divide coefficient by coefficient, variable by variable, and variable by variable, and that will give you it, right? So next is minus 1/3 divided by 1/3. Anything divided by itself is 1. It doesn't matter what it is, right? So 1/3 divided by 1/3 will just give you the 1, and pi times pi will just cancel out. R square times R square will just cancel out. Same thing, it'll just give you 1. We already have 1 there, and then H. So 1H or H, right? 1H and H are the same thing. So let's put H. Everybody following so far? Should be able to work some exercise questions. We will go through those questions next week. I will just ensure that you guys next week, what we'll do is I'll give you guys the exercise, you'll work them, we'll go through them, right? I won't give you all of them to do because it'll take too much of the session time. You guys will do them, we'll go through them, and then we move on to the other step, right? We do the same thing. I will show you how to do it. I will work a lot of examples. We will go through the examples together once I've covered enough, and then I'll give you an exercise. You guys will work them. Next class, and give you exercise. You guys will work them. Then we move on to the second method. That's the way we're gonna do these factorizations, right? But that's gonna be it for today. Have a blessed afternoon as usual. Don't go outside unless you have to, and take your vitamin C's.
Bye.
Good day.